The God Machine. Nazi Germany's Orbital Death Ray. Chapter 1. May 1945. Hillersleben. The blueprints cover an entire wall. American intelligence officers from the 9th Army stand in the evacuated artillery, proving grounds at Hillersleben, Germany, staring at technical drawings that belong in science fiction. A space station 8,200 kilometers above Earth. A mirror 3 square kilometers wide made of pure metallic sodium. Mathematical calculations predicting focused sunlight hot enough to boil oceans, hot enough to ignite cities. Captain Robert Williams, Office of Strategic Services pages through captured documents dated February 1945, just 3 months earlier. The Germans were still calculating mirror curvature coefficients while Berlin burned. They were solving orbital mechanics problems while Soviet tanks rolled across the Oder River. They were designing magnetic boots for zero-gravity construction crews while the Third Reich collapsed into rubble. The lead German scientist, when interrogated, speaks with calm certainty. The Sonnengewehr, the sun gun, could be operational in 50 to 100 years, not decades, generations. He shows Williams the staging calculations. The V-2 rocket, Germany's most advanced launch vehicle, can barely reach the edge of space at 100 kilometers. The sun gun's orbital platform would sit 82 times higher. The amount of metallic sodium required approximately 1 million tons. The number of launch vehicles needed to carry prefabricated sections into orbit, thousands. Williams asks the obvious question: did you actually believe this could work? The scientist's response: Herr Oberth proved it was possible in 1929. Hermann Oberth. The name appears on document after document. The father of the sun gun. The man who conceived a mirror in space that could reshape civilization or destroy it. Chapter 2. 1923. The Space Mirror. Hermann Oberth is 29 years old when he publishes Die Rakete zu den Planetenräumen, the rocket into planetary space, and the scientific establishment dismisses him as a dreamer. His doctoral dissertation on rocket science was rejected by Heidelberg University in 1922 as utopian. So Oberth published it himself, 92 pages of mathematical proofs demonstrating that liquid-fueled rockets could reach orbital velocity, that space stations were physically possible, that humanity could leave Earth's surface permanently. Buried in the technical calculations is a visionary proposal, a giant mirror 100 meters wide, mounted on an orbital platform capable of reflecting concentrated sunlight onto specific points on Earth's surface. Oberth's calculations are precise. The mirror would focus solar energy into a spot approximately 2,000 square miles in area. The temperature in that spot hot enough to thaw frozen rivers, illuminate polar regions. During winter darkness, generate electricity through massive steam turbines. It's weather control. It's climate engineering. It's the ability to provide light and heat anywhere on Earth, anytime, regardless of season or geography. My space mirror. Oberth writes, is like the hand mirrors that schoolboys use to flash circles of sunlight on the ceiling of their classroom. A sudden beam flashed on the teacher's face may bring unpleasant reactions. Unpleasant reactions. The understatement is deliberate. Oberth knows exactly what he's proposing. A mirror that can illuminate cities can also burn them. A beam that can thaw rivers can boil them. The same technology that could feed millions through extended growing seasons could incinerate millions through focused solar radiation. But Oberth frames everything in peaceful terms. The space mirror exists to benefit humanity, to create electricity without coal, to illuminate shipping lanes through Arctic darkness, to extend daylight in regions where winter nights last months. He emphasizes peaceful applications throughout his work. The world doesn't listen. Rocket science in 1923 is fantasy. Space stations are pulp fiction. Giant mirrors in orbit belong in Jules Verne novels, not serious scientific journals. By 1929, Oberth has expanded his original work into a 429-page tome, Wege zur Raumschifffahrt, Ways to Spaceflight. The book becomes the Bible of rocketry, studied by enthusiasts across Europe. Among them, an 18-year-old student named Werner von Braun, who helps Oberth test his first liquid-fueled rocket engine that same year. The space mirror concept grows more detailed. Oberth now envisions structures 90 miles wide, assembled in orbit by astronauts working in diving suits. He hasn't yet conceived of spacesuits connecting cables, like spiders, weaving webs, creating hexagonal cells, each several kilometers across. Each cell contains a movable circular mirror made of thin sodium metal foil. The entire structure rotates to maintain tension. The pressure of sunlight on the vast surface maneuvers it in orbit with steering, accomplished by adjusting individual mirror angles. Construction time 10 to 15 years, cost $3 billion, an astronomical sum in 1929. And still, Oberth insists on peaceful purposes: weather modification, climate control, illumination of the polar regions, the ability to influence barometric pressure areas to guide rain systems to prevent droughts and floods. He does add one chilling footnote. These mirrors could potentially serve as weapons. Given this aspect, coupled with the complexity of the project, realization would only be feasible as a peace initiative undertaken by all humanity. In 1929, this caveat seems unnecessary. No nation possesses the technology to reach space. The idea of weaponizing orbital mirrors is absurd. Then Adolf Hitler becomes Chancellor of Germany in 1933, and absurdity becomes official policy. Chapter 3. 1943. Hillersleben, Artillery Proving Grounds. The scientists at Hillersleben don't know when the project officially started. There's no memorandum, no Führer directive, no budget authorization from the Reich Ministry of Armaments. The Sonnengewehr simply emerges from the chaos of Germany's desperate search for wonder weapons, Wunderwaffen, that might reverse the tide of war. By 1943, Germany is losing. The Eastern Front has collapsed at Stalingrad. Allied bombers pound German cities nightly. The Kriegsmarine's U-boat fleet is being destroyed faster than new vessels can launch. Conventional weapons aren't enough. The Reich needs miracles. So they pursue miracles. The V-2 rocket, the V-3 supergun, the Horten Ho 229 flying wing, the Messerschmitt Me 262 jet fighter, the Type 20 submarine, the Bachem-Ba 349 Natter rocket interceptor. Projects consuming resources. Germany doesn't have pursuing timelines. Germany can't meet chasing technologies that won't arrive until after the war is already lost. Among these fantasies, the Sonnengewehr stands out for sheer audacity. The Hillersleben team takes Oberth's 1929 concept and weaponizes it. They expand the mirror from 100 meters to over 3 kilometers, in diameter 9 square kilometers of reflective surface. They calculate the optimal orbit 8,200 kilometers above Earth, high enough to provide continental coverage, low enough to maintain focused beam intensity. The material selection is critical. Metallic sodium is chosen because it's highly reflective, relatively abundant, and lightweight. Under normal conditions, pure sodium tarnishes rapidly and reacts violently with moisture. It can explode in contact with water. But in the vacuum of space, these properties become irrelevant. Sodium won't oxidize. It won't corrode. It will simply reflect sunlight with near-perfect efficiency. The calculations predict a focused heat beam capable of raising surface temperatures to approximately 392 degrees Fahrenheit. Hot enough to ignite wood, hot enough to detonate ammunition, hot enough to cause widespread fires in any city targeted, hot enough to flash boil water in reservoirs and harbors. The space station supporting the mirror would house a crew equipped with magnetic boots for working in microgravity. Hydroponic gardens would grow pumpkin plants, thousands of them, to generate oxygen through photosynthesis. Solar-powered steam dynamos would provide electricity. The station would receive encoded orders via radio or telegraph and use rocket thrusters to orient the massive reflector with precision. Transportation of materials poses the greatest challenge. The V-2 rocket can lift approximately 1 ton to the edge of space. The Sonnengewehr requires 1 million tons of sodium alone, plus the structural framework, plus the space station, plus the life support systems, plus the propellant for orbital maneuvering. The engineers propose the A-11 rocket, a scaled-up version of the V-2 designed by Wernher von Braun's team at Peenemünde. The A-11 exists only on paper. Building it would require resources Germany doesn't possess. Launching thousands of A-11 missions would require fuel. Germany doesn't have from factories. Allied bombers have already destroyed, protected by Luftwaffe fighters that no longer exist. None of this stops the calculations. The Hillersleben scientists continue their work throughout 1944 and into early 1945, even as the Red Army crosses the Vistula River, even as American forces breach the Siegfried Line, even as the strategic situation becomes utterly hopeless. They're solving an engineering problem that won't matter for a century. They're designing a weapon for a Reich that has months left to exist. Chapter 4. The Physics of Impossibility. The fundamental flaw in the Sonnengewehr is optical physics that a high school science teacher could identify. Light doesn't work the way the Hillersleben scientists needed it to work. When you reflect sunlight with a mirror, the beam diverges based on the distance from the mirror to the target and the size of the light source, in this case, the sun itself. From 8,200 kilometers away, even a 3-kilometer wide mirror can't focus sunlight into a point small enough to generate destructive temperatures. The math is straightforward. The sun subtends an angle of approximately ½ degree as viewed from Earth. When you reflect sunlight from orbit, that ½-degree divergence creates a spot roughly 73 kilometers wide for every 8,200 kilometers of distance. A mirror in the proposed orbit would create a warm area, not a burning point. Oberth himself acknowledged this in later interviews. A 9-square-kilometer mirror would create a heated spot about 2,000 square miles, in area far larger than the diagrams suggested. The temperature increase would be equivalent to normal equatorial sunshine. Uncomfortable, certainly. Enough to cause some agricultural stress or mild heat-related casualties in unprepared populations. But not enough to melt cities, not enough to boil oceans, not enough to justify the term death ray. To actually achieve destructive temperatures, you'd need a mirror double the calculated size 18 square kilometers, which would increase heat intensity 4 times. And you'd need it significantly closer to Earth, which creates orbital instability problems. and you'd need atmospheric conditions that prevent the beam from scattering, which you can't control. And you'd need the target to remain stationary for extended periods while the focused heat accumulates, which no military force would allow. The Hillersleben scientists weren't fools. They understood optics. So either they were deliberately misleading their superiors about the weapon's capabilities, or they were engaged in a massive exercise in theoretical engineering with no expectation of practical deployment, or they were creating bargaining chips for the inevitable Allied occupation. The evidence suggests all three. Nestled among the death ray diagrams, the captured documents include extensive notes about peaceful applications, radio relay satellites, weather observation posts, launch platforms for interstellar expeditions, electricity generation on Earth using Oberth's original steam turbine concept. The scientists knew the war was lost. They knew the Sonnengewehr would never burn cities. But they also knew that demonstrating advanced thinking about space technology might earn them clemency or employment from the victorious Allies. They were right. Chapter 5. Operation Paperclip. Wernher von Braun surrenders to American forces on May 2, 1945, along with 500 of his colleagues from Peenemünde. The United States Army moves quickly to secure German rocket scientists before Soviet forces arrive. Operation Paperclip, the program to recruit German scientists and engineers, evacuates over 1,600 technical personnel to America. Many of them worked on projects related to the Sonnengewehr. Von Braun designed the A-11 rocket meant to carry mirror components into orbit. Hermann Oberth, the concept's originator, eventually relocates to the United States and works under his former student at NASA. The engineers who calculated sodium requirements, orbital mechanics, and beam intensities all find themselves employed by the U.S. military-industrial complex. The sun gun itself becomes a curiosity. Life magazine publishes a feature in July 1945, Science Sun Gun. The article describes the weapon with breathless drama, but acknowledges German scientists' claim that completion would require 50 to 100 years. The American public reads about Nazi death rays from space with the same fascination they'd show for Buck Rogers serials, entertained but untroubled, knowing the threat never materialized. The technical documents disappear into classified archives. Some aspects influence early U.S. space-based weapons research during the Cold War. Concepts for orbital platforms, solar power generation in space, and large-scale structures assembled in orbit all draw from the Hillersleben work, though carefully scrubbed of their Nazi origins. Von Braun himself champions space-based weapons throughout the 1950s. He lobbies the U.S. military to build orbital battle stations capable of reconnaissance and weapons deployment. In lectures to the Armed Forces Staff College, he presents ideas remarkably similar to the Sonnengewehr's, supporting infrastructure manned platforms, nuclear-tipped missiles, preemptive strike capabilities from orbit. His Collier's magazine articles in the early 1950s depict wheel-shaped space stations that bear suspicious similarity to Hermann Oberth's 1923 designs. The centerpiece of von Braun's vision is space superiority. Military dominance achieved through orbital platforms that can strike any target on Earth with impunity. It's the Sonnengewehr concept, stripped of its death ray mirror, but retaining its fundamental strategic principle: whoever controls orbital space controls Earth. The U.S. military, fortunately, declines to pursue orbital bombardment platforms. The Outer Space Treaty of 1967 explicitly prohibits placing weapons of mass destruction in orbit. Von Braun's vision dies, but not before influencing decades of strategic thinking about space militarization. And Hermann Oberth, now living in America, continues promoting space mirrors. In a 1961 interview, he proposes the United States build a mirror 300 miles in diameter, far larger than his original concept, capable of terraforming Earth using materials sourced from the moon. He frames it entirely in peaceful terms: climate modification, agricultural enhancement, illumination of polar regions during winter darkness. He's 77 years old, and he's still selling the same dream he published 38 years earlier. The dream that became a Nazi nightmare. The dream that never left the drafting table. Chapter 6. The Legacy of Light. No nation has ever built an orbital mirror weapon. In 1993, Russia launched Znamya 2, Banner 2, a 20-meter diameter reflector that successfully reflected sunlight onto Earth's surface from orbit. On February 5th, observers across Europe saw a dim flash of light traveling across the night sky from France to Russia. The experiment created a 5-kilometer-wide bright spot visible from the ground. It was the first and only time a space mirror was successfully deployed. The Russians planned a larger version, Znamya 2.5, but the deployment mechanism failed during launch in 1999. The project was abandoned. The equipment burned up in the atmosphere. Znamya 2's bright spot wasn't weaponizable. It was barely brighter than moonlight. But it proved Oberth's basic concept. You could reflect sunlight from orbit onto specific locations on Earth. The physics worked. The engineering was achievable. The question was never whether space mirrors were possible. The question was whether they had any practical application worth the enormous cost and complexity. Modern proposals for orbital reflectors focus on extending solar farm operation hours, passing mirrors that briefly illuminate ground-based photovoltaic arrays during evening and morning hours when demand peaks but sunlight is unavailable. It's precisely what Oberth envisioned in 1929: peaceful energy generation using space-based infrastructure. The death ray version, the Sonnengewehr, remains impossible. The physics doesn't support it. The economics are absurd. The strategic value is questionable, even if it worked, given that ballistic missiles can destroy targets far more reliably than focused sunlight. But the legend persists. Nazi Germany's sun gun appears in documentaries, books, video games, alternate history fiction. It's become shorthand for Nazi wonder weapon that almost worked. Never mind that it never progressed beyond calculations on paper. Never mind that the physics were wrong. Never mind that no prototype was ever built or tested. The myth is more compelling than the reality. The reality is a group of scientists in a dying regime calculating orbital mechanics while their nation collapsed, solving engineering problems for a weapon that wouldn't matter for a century, creating bargaining chips disguised as blueprints, hoping their futuristic visions would buy them safe passage through the Allied occupation. And it worked. Hermann Oberth lived to see humanity actually reach space. He watched the Saturn V rocket, an evolution of the A-11 his colleagues designed to carry mirror components, carry Apollo astronauts to the moon. He saw communications satellites, weather satellites, Earth observation platforms, everything he'd predicted in 1923 finally become reality. He died in 1989 at age 95. By then, the Sonnengewehr had been debunked repeatedly. Physicists had explained why it couldn't work. Engineers had demonstrated why it wouldn't be built. Historians had revealed its origins as more fantasy than project. But the legend lived on. And perhaps that's fitting. The sun gun represents something larger than just a failed Nazi superweapon. It represents the eternal tension between scientific vision and military application, between dreams of benefiting humanity and nightmares of destroying it, between what's theoretically possible and what's practically achievable. Chapter 7. The Mirror's Reflection. In 2024, climate engineers discuss space-based solar reflectors as part of solar radiation management geoengineering schemes to combat climate change. The proposals sound remarkably like Oberth's 1923 concept: large mirrors at Lagrange, points between Earth and Sun, capable of modulating how much sunlight reaches the planet, controlling regional temperatures, influencing weather patterns. The physics works. The engineering is achievable with modern technology. The cost remains astronomical, and the geopolitical implications are terrifying. Whoever controls the mirrors controls global climate, creating massive potential for abuse, accident, or weaponization. It's the Sonnengewehr again, reborn under a different name, with ostensibly peaceful intentions. And the same warning Oberth gave in 1929 still applies. These mirrors could potentially serve as weapons, and their realization would only be feasible as a peace initiative undertaken by all humanity. We haven't achieved that level of global cooperation. We probably never will. Which means space mirrors, whether for climate engineering, agricultural enhancement, or energy generation, will remain in the same category they occupied in 1945. Theoretically possible, practically unachievable, potentially dangerous if deployed. The God machine was never built. The orbital death ray remained on paper. The Sonnengewehr fired only in propaganda, in legends, in the fevered imaginations of people who believed Nazi Germany possessed technologies beyond comprehension. But Hermann Oberth's dream, the original dream from 1923 before it was corrupted into a weapon, that dream is still alive. Orbital reflectors for peaceful purposes, climate modification for agricultural benefit, illumination of polar regions, energy generation in space. All of it remains theoretically viable, waiting for a civilization mature enough to use such power responsibly. We're not there yet. We might never be. But the blueprints exist, captured in 1945, from a dying Reich, stored in American archives, studied by generations of engineers who looked at the calculations and thought, this could work. This could actually work. Maybe that's Oberth's real legacy. Not the sun gun that failed, not the Nazi nightmare that never launched, but the persistent dream that someday humanity might be wise enough to build mirrors in space, not as weapons, but as tools. Not to destroy, but to illuminate. The mirror waits. 3 kilometers wide, made of sodium, that doesn't tarnish in vacuum, reflecting sunlight onto a world that doesn't trust itself with such power. It waits in blueprints, in calculations, in technical drawings spread across a wall at Hillersleben in May 1945. It waits for a civilization that doesn't exist yet. And maybe that's for the best. The schoolboy's mirror flashing circles of sunlight on the classroom ceiling, harmless play with dangerous potential. Hermann Oberth understood this from the beginning. A sudden beam flashed on the teacher's face may bring unpleasant reactions. The sun gun never fired. The teacher was never blinded. The world was never burned. But the mirror still gleams in someone's imagination, waiting for the day when humanity is ready for such power. That day hasn't arrived. and every year it doesn't arrive, we should be grateful.